So this should be working. So good morning again, everyone. We are going to get started on our lecture today. We are still in the same module, module 1. This is lecture 4, if I got that right. Let's see. Yes, I got that right. Okay. So what we have seen so far is we have been talking. Let me make sure that I keep the chat visible here. I'm hearing some messages. Where is my chat? Come back. There we go. Out of curiosity, are we going back on campus next week or this first day? We are going back on campus next week. That would be like the 2-week mark. So everything should resume normally Tuesday until the next time we have to switch back online. We'll go with the flow. We'll adapt. Don't worry. All right. So sorry, I had to ask that quick question there. I thought it was a good idea to get that done before actually we start. So what I was going to say is we have been covering so far the core OO concept, like the very basic stuff that generally some people even like to just start new programmers, with classes, object, attributes, and method. Okay, so very basic stuff. This is going to be the bread and butter for IE 1, and I'm going to talk a little bit more about the upcoming intermediary exam in one slide. Okay. Then we consider some example, to discuss a little bit about what OOP was good for. We have been spending a lot of time last lecture going through constructors. So that's one of the first, mechanics, OOP mechanics really that we looked at in detail. And then what do we have left to do? So we have probably enough material for this lecture today, the lecture Thursday, and I should have enough time next Tuesday to do a little review, wrap up example, so that you have something that looks very comparable, to the IE, to the intermediary exam, so that we can use it, as a sort of a live coding / review session. Okay, so this is the plan. So today and the next lecture, we are going to still go over a few more concepts that are essential in object-oriented programming. We are going to talk a little bit about passing objects to method. That's not really a main concept, but this is something that I need to talk a little bit about so that I connect it to everything that we've done before when we did, for example, the swap method and stuff like that, the concept of passing by value, passing by reference. We need to make sure that all of that connects 100% with objects. Okay, we're going to talk about immutability, another topic that we already breached. We talked about it. We talked a little bit about the consequences of some object and class being immutable. We are going to wrap this up now. We're going to finish up that topic. We're going to then introduce the concept of visibility, and more specifically, the few keywords in Java that are used as visibility modifier. So spoiler alert, it's going to be public, private, and that's it for now. Public and private. We've encountered those. At least the public keyword, we've encountered it like since day one. Okay, public static void main, public class something. It's been already everywhere. We never really took the time to explain, if we add any alternative to using just public. Well, that's going to be taken care of, in those 2 lectures. Then we're going to talk about the des keyword. So I'm not going to do a preview on that one because I find that previews on the des keyword tend to be more confusing. So it's just a new keyword in Java. Let's wait for the right time in the slide and I'll introduce it properly. Okay. And then the last thing that we're going to wrap all of this up with is reviewing again, going back again onto the difference between static and non-static, but we are not going to stop at methods. We're going to talk about static versus non-static methods, static versus non-static attributes, and static versus non-static constants defined in classes. All right, and we're going to have a kind of an all-encompassing example here where we are trying to explore all possible combination of this stuff. Those of you who already took classes with me, this is something that I like to do. When you have like 2 knobs that you can turn, I like to try every possible combination to make sure that I really understand how those things interact with one another. And I do the same when I try to explain to other people. So when I try to explain to you, as static and non-static differ, I really want you to see all the possible situation that you might encounter later. And like I said, when we are done with all those extra concepts, which should take us, 2 sessions, maybe we're going to speed over a little bit. Maybe we're going to be faster than last year. I don't know. But once we are done with those concepts, then we'll spend a little bit of time going over comprehensive examples to wrap up this module nicely and to help prepare you for IE1. Talking of which, we have PQ1, P1, and the reading assignment have been available since day one. I have students that ask me where are the practice exercise, where is the practice quiz. So every time we start a module, the first lecture of that module is going to tell you about the practice exercise that are recommended for the entire module. Okay, and at that very moment, when we release the first slideshow for the first lecture of a module, the PQ is going to be available. The P's are going to be there in the slide, and the reading assignment are going to be also there in the slide. And then remember, what I want you to do is I want you to do this incrementally a little bit at a time as we cover the material in the lecture. So don't wait for the end of the module to start the reading assignment or to start using the practice quiz. Okay, it pays off a lot more if you do it, all along. And so what we need to wrap up this module is we need a graded quiz and we need an intermediary exam. So the graded quiz right now is scheduled to be released next Monday. So next Monday, you're going to have the graded quiz due at 11:59 p.m., something like that. I think you can even take it earlier than that, but don't take my word on those deadlines. Just check, in the syllabus section of Canvas. And the IE1, my plan right now for IE1 is to release it a few days after the GQ. So right now I'm targeting the Friday of the same week, right? So the GQ is going to be released next Monday. The IE01 should be released at the end of that week. So that's going to give us enough time to finish, the lectures on module 1 and to even have like one session to do some sort of review or something like that. Before you have to take actually IE1. And we are settling, by the way, in our routine, the routine that we are going to use up to the end of the semester, which is about every 2 weeks, there is going to be an intermediary exam. That's going to keep you, at the right pace. Nobody's going to fall behind because every 2 weeks you have something to prepare. At the same time, this is not, like having an exam every week. So it's a lot less stressing than if we had like an exam or even a shorter exam, every week. So I found in the past that 2 weeks was kind of a good pace, to give you feedback. And we are going to try to maintain that pace up to the end of the semester so that you have a bunch of IEs under your belt. The advantage of having a bunch of IEs this semester is, one, that the goal of the IEs, like I explained in the first day lecture, is to prepare you for the final exam. The final exam is worth 30% of the grade, I think. It's a big chunk. So we want to make sure that you walk into your final exam with the best preparation possible. And number two, the second advantage of having a lot of IEs regularly is not only that keeps you learning and studying, regularly instead of trying to cram at the last minute, but it's also going to give me an opportunity to maybe drop the worst IE grade like I try to do in every one of my course, okay? Every one of my course, once I am sure that we have a good pace in the course and we are going to have at least, 5 or 6 IEs for the student in terms of grades, then generally I go into Canvas and I select, policy, drop the worst IE so that everybody gets one, okay? No matter the reason for which you had a bad performing IE, maybe you were just learning something that you missed, you are not going to have this, completely cripple your end of semester grade. So everybody's going to get like a freebie, sort of speaking. But I'm not going to make promises yet. I'm just waiting to see if we can actually indeed maintain that pace. In the past, this has not been a problem. So finger crossed, we're going to be able to do it again this semester. All right, last word. Actually, I didn't put it on the slide, I forgot, but IE0. IE0 is graded. So you received feedback from from the TA who graded you. This feedback should consist of a rubric, a grading rubric that gives you the points that you earn or lost for each item. Sometimes some TA like to put comments in the grading rubric itself. Other TAs put the comments separately. using the right-hand side panel. When you click on your grade in the gradebook and you open it up, you're going to see a right-hand side panel where you can actually dialogue with the grader. And generally, this is where they leave you the feedback. So that feedback is expected to be detailed. If it's not detailed, then we're going to talk about the next step, okay? But even if it's detailed, I really encourage you to take the time to meet with your grader. This is the first step, okay? This is level 1 tech support between quotes, okay? You just got some feedback, you just got a grade, you just got some feedback. Maybe the feedback is not clear, maybe you don't understand exactly what the grader meant, okay? Like I have students that reported that some of the feedback was, for example, in the lines of, you failed some extra tests. Well, as a student, I would be super curious to know exactly what are those extra tests that I failed. What's wrong with my code, because it looked like it was working. So besides the fact that you may want, to double check there's no grading error and stuff like that, it's also an opportunity to learn from every single one of the mistake you might have made. Okay. And if we keep that going, if you meet with your grader every time after every IE, it doesn't have to be long, but you go over the exam with them, you ask all the questions you have about the feedback. And if really you were lost at that exam, then you sit down with your TA, and you ask them, hey, can we go over it together? Can I try to redo it? And you'll be standing by, ready to help me if I have a problem. All of those kind of things, depending on what you need, are exactly what is going to help you benefit from the IEs in terms of preparing for the final, okay? So not only your IE grade should be improving if you do that as we go forward, because you're not going to make the same mistake that you made at the beginning of the semester, but by the time you reach the final, the goal is really for you to be rock solid, okay? All right, so that's it for the public service announcement. Now let's jump into the first topic that we had listed for this lecture, which is passing objects to method. So not too many things that are going to be new here. It's more like, again, trying to put a second layer on concepts that are already breached and trying to make sure everybody's on board with them. So that there are two mechanisms for passing parameters in Java when you call a method, right? When you call a method, you are going to pass by value any primitive data type, okay? So you pass an argument, which is a variable. I look inside that variable, pick up the value, and this value is copied into the parameter of my method. So people refer to that as passing parameters by value. And it's for primitive data types. Actually, it's not really for primitive data types only, because the second method for passing parameters in Java is also passing by value, actually. All right, I explained that when we covered it a few lectures ago. I'm going to re-insist on it today. There's only one thing that you do when you call a method in Java. You pass parameters by value. Because whether it's a primitive data type or whether it's a reference data type, and so the value that you copy is either, an int, long, short, whatever for primitives, or a reference to an object for the reference data type, it's still the same mechanism. You take your argument, you evaluate your argument, it gives you a value, you copy that value into the parameter, the corresponding parameter, and there you go. So we could argue, that people say we pass primitive data types by value and we pass objects by reference. What they mean is that we pass a reference, which is a very special type of value that allows the method to modify the object once it has a reference to it, okay? So if this is confusing a little bit, it should be a little bit confusing, just a little bit if you missed, the last time I introduced it. Ask question. Let me help you detangle that, but don't give up on it, okay? It's not because something is initially confusing that you should turn around, run away from it. No, it's quite the opposite. So ask question on Piazza, come to office hours, let's detangle that. This is a good self-check for you. If you really understand what I just said right now, you are rock solid on passing argument to method. If not, then there is room for improvement. Let's work together on it, all right? So let's take an example here, because beside that little, point here that I wanted to make, it's going to be relatively easy to understand what's going on here. So let me move this guy out of the way a little bit here again. All right. So we are taking an example here where we have a class called test pass object. So it's just a class that we wrote to test and play a little bit with passing objects to method. We have a main method inside that class. So the main method is a static method. We are going to only have static methods. Okay, we are not going to create another class and create objects of that class. Here we are just trying to illustrate, passing objects to method. So inside my main method, somewhere, I'm assuming that I still have that simple circle class that I defined last lecture. So I'm going to say, let's create a simple circle object of radius 1. So remember how that works, right? The new keyword creates the object. Then I call the constructor that takes one argument on that object. The argument here is the value of radius. The constructor is going to initialize the object with a radius of 1. And then I put the reference to that newly created object into the reference variable named my circle. Okay? So 4 steps. In case you want to double check your memory, 4 steps that we detailed last lecture about this. Try to recall them. And if not, check the video or the slide even. So what do we do once we have a simple circle of radius 1? Well, we are going to say call the method print area. So this is not a common method, like a standard method of Java. This is something I'm going to write like right below, okay? So call the method print areas, plural, and pass my circle to it and a value n, which is right now 5, okay? And then, once I return from calling that print areas method, display on the screen, the radius is blah, blah, blah. So how do I get the radius of the object that is being referred to by my circle? I use a dot notation. Again, refer to previous lecture, right? So the name of the reference variable, dot, and here could come the name of an attribute or the name of a method. Well, it just so happened that I have a method called getRadius, which only job is to return the value of the attribute radius. Sounds kind of dumb, but it's very common in object-oriented programming. It's called a getter method. So get followed by the name of an attribute. Generally, that means that you want to obtain the value of that attribute. Why would you even need a method like that? Why not use the attribute directly? We're going to talk about that in a few slides, okay? But there is a reason. There is a reason to this madness. What else? So we call myCircle.getRadius. That tells us what is the current value for radius inside this object, and I display that on the screen, and then I display the value of n. And no surprise here, okay? If n is 5 before to call print areas, I pass here. I don't pass n, I don't pass the variable n, right? Remember, pass by value. So I have an expression here that is just the variable n. I evaluate it, it gives me the value 5. It's a value 5 that I pass. So there's no way n is going to be changed. So this is just a double check, a sanity check to make sure that, yeah, passing primitive data type by value still works the same way. What about my circle? Maybe my circle was modified. Its initial radius was 1. I gave it to a method that says I'm going to print areas. I don't know yet exactly what it does, but if that method by any chance was modifying the radius, I would be able to tell here because the radius would be different than 1. Okay? All right, so let's take a look at that print areas method that we keep talking about. So it's right there, right below the main. So inside my class, I have a main method here, and then separate from it, right after it, a print areas method, which is also a static method, okay? So what does it do? Well, first, it returns nothing, void. So that's clear, that's out of the way. And you see that when we use the method, we don't assign its return value, to any variable or anything like that. We don't use its return value. We don't expect a return value. Well, that's consistent with the way the method is declared. Print area takes 2 parameters. Well, that sounds good because here I passed 2 arguments. The first one is a reference to an object of class simple circle. Let's see, my circle contains a reference to such an object, so we're good. And the second parameter here is the value of n that is passed as argument, which is called times here. And it's going to tell me how many times I want to repeat an operation inside this loop. You're going to see exactly what I mean in a second. So inside the method, I start by displaying radius, to tabulation, and area. So I'm going to display a column on the screen. The first column is radius, the second column is area. So I'm going to tell you for a radius of this much, this is a corresponding area. All right, very well. So while times minus minus greater than 1, so it looks like I'm using the parameter times as a counter. So it's a counter control loop, and it's going to iterate starting with the value times, then decrement it by 1. So for example, it's going to do if times is 5, like in our example. Time is going to be equal to 5, then 4, then 3, then 2, then 1, and then we stop. Okay, so I'm going to use times actually as a counter for my loop. Okay, and I want to iterate 5 times because I was passed the value 5 here as a parameter. All right, and what do I do each iteration? System.out.println c.getRadius. Again, dot notation. C is my reference to the same object that was created in the main. So this is why we talk about passing by reference, okay? Yeah, the reference was passed like any other value. It's just that when you have a reference value somewhere, you can access the same object that is referenced by that reference, right? So both the main using the variable myCircle and the method printArea using the parameter c access the same object. So I want to see the radius. The first time is going to be 1, okay? I display the radius of 1 in the first column, and then I ask it to compute its area and give me the area of the circle. So a circle has a radius of 1. I get the area corresponding to a radius of 1, display it on the screen. And then I use set radius. So I told you there are some methods that are called getters, right? That generally are named get followed by the name of an attribute, and all they do is return to you the value of that attribute. Well, similarly, there are methods called setters that are generally called set and then followed by the name of an attribute, and those methods allow you to change the value of that attribute. Again, we could use a dot notation to write c.radius equals a new value. Okay, so we have a choice here. We can just use a dot notation to access directly the attribute, or we could use a dot notation to use both setters and getters methods to actually change and obtain the value of the attributes. Okay, again, we're going to discuss very, very soon why that might be an advantage again, actually. So the next step in the loop is c.setRadius. Let's change the value of the radius, and I'm going to change it to be the current value, so c.getRadius again, plus 1. So here's my loop going 5, 4, 3, 2, 1, counter control loop, okay? My radius, when I pass the object, was 1, so I display radius 1, this is the area. Then I increment the radius by 1. This is what this line here is doing. Set the radius to the current value plus 1. So now my radius is 2. Go again through the loop, display radius 2, and compute the area that corresponds to a radius 2. So you got it. We are going to have a table that's going to say 1, 2, 3, 4, 5 for the value of radius. And in front of each radius value is going to display the corresponding area using the class simple circle that we talked about during the last lecture. Okay? To give you a visual representation of what's happening here with the parameter passing, because it's really the parameter passing part that is important, okay? It's not the computing areas and stuff like that. We've seen that, we've done it, been there, done that, got the shirt, you know. So this is not the most important. What's the most important is to stitch that together with the program activation, the activation record that are dropped on the program's execution stack. So here's a diagram that's supposed to represent the memory. The stack area of the memory is here on the left. Okay, so you remember program execution stack. Sorry, I cannot speak this morning. Program execution stack is where we store all of the parameters, the local variables, etc. For every method that is running, we have what is called an activation record. So when you start your application with the main, you have an activation record that contains the variable n and the variable myCircle. N contains the value 5. MyCircle contains a reference to an object of class simple circle that was created elsewhere in memory. So until now, I told you always elsewhere in memory, elsewhere in memory. Well, let's give it a name. That other area of memory that is separate from the program's execution stack, or the stack for short, okay? That other area of memory where all the objects are created is called the heap, all right? So technically in memory, the stack will be, for example, at the beginning of your memory, the heap will be at the end. Okay, and if they ever meet one another, you run out of memory. So we separate clearly where the objects live from where the variables, the local variables, the parameters inside method actually live. So that means that any primitive data type here is going to be inside its own variable, okay? Any reference data type is just going to refer to something that is actually located right there in the heap. So my circle refers to that object of radius 1 that we create. Then we call print area, and activation record is pushed onto the stack to give some memory for print area to do its job. Print area needs to store the value of parameter times and the value of parameter c. Perfect. So here they are. Okay. Times contains 5, primitive data type. It contains a value. C is a reference data type. It contains a reference that refers to the same object than my circle was referring to in the main. So those two arrows pointing on the same object inside the heap really shows you how we can pass an object, quote unquote, by reference to a method, right? I pass the value of the reference, but now both the method and the main are capable to access the object. And this is exactly what we have been dealing with when we are playing with the swap method, right? So now they are both able to access the setter, the getter method, the attribute, and stuff like that, and potentially modify this object. Well, let's take this, which is what we already discussed, when we had that swap method, and let's add one layer on top of it. What happens if I have an array of objects? So we have not been manipulating many arrays of objects until now. Okay, we've seen one example so far, something like that. So we're going to try to make that a more common occurrence before IE1, sorry. So what happens if I have an array of objects? Well, it's kind of like, one way to look at it is to say I have two levels of referencing now. Okay, so two levels of referencing means that if I say, for example, I have a reference variable circle array, okay, it contains a reference to an object of class simple array of simple circle. All right, so an array of simple circle, what does that mean? That means that this is an object of class array of something. So here's my object that is my array. Inside the object of class array of anything, you find slots. Okay, we have here 10 of those slots. You can see here the code that we use to create this. Okay, circle array is a reference variable meant to hold the reference to, and we read that right to left, to an array of simple circle references. Okay, so here we are. I have my array of simple circle references, and those slots are going to contain in turn reference to what? To object of class simple circle. But watch out. The first thing you need to understand is when I write this line of code here, I create one object here. This one object, even though it's an array of 10 elements, okay, it's one array. So when you execute this line, you have this part here, you have this part here, but each of the slots here contains null. They do not yet point to the circle object. When am I going to finally point to the circle object, simple circle object? When I finally get around to creating them one by one and putting the reference of each of them inside the corresponding slot of the array. All right, so creating an array, simple. New simple circle, square brackets 10. There we go. I have an array meant to hold 10 references to object of class simple circle. Meant to hold references. Yeah? Right now the references are null. The objects of class simple circle are not even on the radar. Okay? So what we're going to do now is we're going to look at an example where we create arrays inside method. We return the reference of that array so that the calling method can use it. Okay, we don't lose it when we end the method. We are going to populate that array with reference to a bunch of other objects. And pretty much if you understand this, then we can progressively stretch it and stretch it and stretch it. And I could ask you, well, what if I want a reference variable to refer to an array object, and that array object each of the slots is going to be a reference to another independent array of reference to a simple circle. I just created a matrix of simple circles, okay? So we are going to look at this example, okay, involving one dimension, but I want you to keep in the back of your head the fact that once you know how to do it with one dimension, you should be able to do it 2 dimensions, okay? Try it, think about it. This is part of studying, material. You kind of think about what you are reading and learning, not just memorize. And if you cannot picture it, if you cannot see it, this is what office hours are for. Okay, so don't hesitate to come see us and say, can we run through some code, take some examples on this? I just want to wrap my head around it. Okay, that's part of the studying of the material. So that example that I promised you, what is it going to look like? So here's a class total area. The name doesn't matter really, okay? We have a public static void main method. Inside that main method, we are going to create, let me move this guy again. We are going to create an array of objects of class simple circle. So the first step is I want one reference variable named circle array that is meant to hold a reference to an array of object of class simple circle. When I execute this line, what do I have? If I go back to the previous slide, what do I have in memory? Hold on, there we go. Only this. There's no array object that has been created. There are no simple circle objects that have been created. The only thing that has been created in memory is, at the end of this line of code, the circle array reference variable. That's it. Then I'm going to call another method. That's a method I'm going to write myself, okay? It's going to be in the next slide. This method is named createCircleArray. It's going to do something. It's going to create an entire array of a bunch of objects of class simple circle. So it's going to do all the job of creating all of those guys here. I mean, this guy here, singular, and all of those guys here, and connect all of them and return to me the reference to the array object. And once I have the reference to the array object, look at what I do with it. I assign it to circle array. So I created a method to do all that job for me, because I could declare here, simple circle square bracket circle array equal new simple circle square bracket with the value 10, for example, in between. That would create an array of 10 reference to simple circle objects, but that's it. That would not create a simple circle object. So instead of that, I say, forget it. I'm going to actually have a method that creates not only the array, but creates also all of the simple circle objects that are meant to go inside the array. And when it's done executing, it returns me the one reference to the array, and I get the full picture that was in the previous slide. Once I'm done with that, I'm going to call another method that I'm going to write myself, print circle array. That one takes a reference to the object of class array of simple circle, and is going to iterate inside that array and look at every simple circle reference we have there, follow the reference, and display some information about the corresponding simple circle object. Pretty cool, right? So we have a method that takes an array of objects and do something useful with it. We have a method that takes nothing, but creates an array of objects from scratch. So this is important for us to look at how this method does its job, and then returns a reference so that I may use it in the main. So you see the passing by reference, it's working backward too. If I return a reference from a method, okay, that object that I created inside the method is still somewhere in memory. It's not wiped out because it's on the heap. So it's not in the activation record that gets wiped out, unlike all of the local variables for that method. And then when I return that reference, then the main can still access that method, that object on the heap. Question from Jake. So how does the code know how many objects are in the array? Wouldn't we have to identify the number in the array? Okay, good question. If we wanted to make this, are you done? If we wanted to make this, if we wanted to make this, how to say, parameterizable, I don't know how to pronounce that, we would just put an argument here. Okay, I think this is what your question is about. Is like, how come I don't say here, for example, I want an array of 10 elements so that the method knows how big of an array to create? Correct me if I misinterpret your question, Jack. Okay, well, we don't because it's going to be hard coded in the method. That's it. Right. So, all right, cool. We're on the same page. So it's just because the method is hard coded. It's just an example. It's going to always make an array of size 10 that we don't have to specify it. But if we were trying to write code that we may be able to reuse, in different projects and stuff like that, oh yeah, definitely. I would put a parameter here that allows me to specify every time how many of those simple circles I want in the array, and therefore, configure the size of the array. All right. All right. Keeping an eye on Sam here. He's playful. All right. So we are going to kind of like work on a method that returns an array created, a method that takes an array that's already created. So we're going to go both ways with arrays of objects here. What else do we have? So now we are going to dig into the code for those two methods. That's what we have left. Okay. Our main is over. Very simple main. Now let's talk about the create circle array method. So simple circle, square bracket, circle array equal new simple circle 5. This is where it's hard coded, Jake. Okay, so it's not even 10, it's 5. I think I've been using 10 as an example. So here what we say is I want reference variable named circle array. It's a local variable inside the method create circle array, which means when you call create circle array, that reference variable comes to existence on the stack. When you exit the method create circle array, that variable will be destroyed. Okay, no need to keep it after the end of the method. But right now, it's going to be a temporary placeholder where we are going to store the reference to a new object of class simple circle array of simple circle, I should say. Okay, so I create here. There we go. Circle array is a reference variable meant to hold the reference to an object of class array of simple circles. Okay, I create such an array object of size 5. So right now the object of class array of simple circle exists in memory in the heap. It has 5 slots inside of it. All those slots contain null. Okay, these slots are kind of attribute inside the object. So you know what happened to attribute that are of data type reference. If you don't do anything to them, they are initialized to null. So all those slots say, I don't have the reference to any object. So here you come, I have an array of 5 slots, each of them saying no object of class simple circle is referenced yet. Awesome. And then I have a loop. Why do I have a loop? Because I'm going to have to do some work on each of those 5 slots one at a time. So it's an array. How do you reference the slots of an array using an index? Here we are. For int I equals 0, so the name of my index variable is going to be I. Again, I is a local variable. It's going to disappear when we exit, create circle array, the method create circle array. But that object here, the array object, that one is not going to be destroyed. That one lives on the heap, right? So for int I equals 0, I lesser than circle array.length I plus plus, counter control loop from COP2513. I'm not going to go and re-explain that, okay? But if you have trouble with it, please come to office hours so we can work with you. So I'm going to iterate over every element of the array. And for every element of the array, what I'm doing is I'm creating an object of class simple circle, okay? One object of class simple circle. I give it a radius value that is pretty much a random number. So there are a few methods, a few classes, sorry, especially the class random and date. I really refer you to the reading assignment for this module because we are not going to talk a lot about them, but we're going to use them in slide example and stuff like that. But the textbook in like just 2 pages gives you all the details on how to use date and how to use random. So please make sure that you study that in the textbook and ask questions during office hours or on Piazza if you bump into any problem, okay? It's just like very, very basic stuff. So generally we kind of skim over it real fast during the lecture. But if you have problem, ask question. Question from Gilberto. I forget for the math.random times 100, is that range from 0 to 99? Yes, you got it. That's exactly what it is. So we generate a random number between 0 and 99. That's our radius. We create an object of class simple circle that has that radius value. So since we have 5 slots in the array, we are going to generate 5 simple circle objects with random radius inside of them. Question from reverse, the random values are not declared as an int for? No, they're not declared as an int. What's declared as an int is the parameter of the simple circle constructor. Okay, we talked about constructor last lecture, so let's connect that, to what we studied last lecture. When I create the object here with a new keyword, once the object exists in memory, Java calls one of the constructor, and here it tries to call a constructor that takes one int value. Actually, sorry, this is going to end up being a double value, one double value as parameter. Okay, so I'm assuming that yes, I did provide in my class simple circle, which I did. I provided a constructor that takes a double as parameter. Okay, and that's the one that's going to be called here. So in a manner of speaking, I declared, whatever is going to hold this value here, the result of evaluating this expression, I declared it when I declared my constructor. Yeah. But that being said, I could have had like a local variable here that's just called, my radius or random radius, and then assign to it math.random times 100, and then pass to here, random radius. Why not? So I could add one extra local variable. It doesn't make a difference. It's not an issue of performance or anything like that. Okay. So I create those 5 randomly sized arrays, and then when I'm done, return circle array. All right. I can do that because all of the other local variables, and if I add any parameters here, all of the parameters, they're going to disappear once I reach the end of my method. But circle array here contains a reference to something that was created elsewhere in memory. Okay, remember, this is a heap. This is where my object has been created. So when this activation record goes away, for example, this object is still there. So if I have a reference on it, guess what? I can still access it from, in this example, that's going to be from the main. So let me rewind to where we were. There we go. And then the last method we have to discuss, print circle array. I'm going to go fast on that one. So that I told you, for the reading assignment, the date class and the random class are important. And now I'm going to tell you in the reading assignment, the syntax of system.out.printf, which is this kind of stuff here, is called the formatting string. That is not important. Okay, so that one you can skim over very fast when you do your readings. Okay, when there are things in the reading assignment that are really important, I will tend to really emphasize them, point them out in the lecture. If there are things that are difficult, I will lecture directly on them. Okay, but if it's just a little detail that I want to make sure everybody catches still, I'm going to make sure that I emphasize it. This is not important. This is just a syntax that allows us to make, again, columns, but this time neatly aligned column. Think about Excel, columns where you can center to the right or the left the values inside of each cell. You can do stuff like that, right? You can truncate the text. Well, okay, that syntax allows you to do the same kind of stuff on your console. If you're curious, come and ask questions to the TAs or myself. We'll be happy to kind of go over that topic with you. Okay, it's fun. But if you are not particularly, curious about that weird syntax with percentages and stuff like that, then you're not missing anything. Don't worry. You're not missing anything fundamental. You are going, if anything, you're going to restudy that syntax when you take COP2513 and you study the C programming language. So don't worry for now. Okay. So here I display the header of my table, and then I have a loop for every element in that array. So you're going to give me a reference to an array, okay? And for every element in that array, I display for the element at that index I, the value of the radius, the value of the area. So it's very similar to what I did before, except that this time I have a whole array of objects that I iterate over. And when I'm done, dash, 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 super user interface there. And then I display the total areas of all the circles in that array is. And I call another method sum that I have not yet defined. And I pass to it again the reference to the whole array. So now all I have left to do is figure out how sum works, because apparently it returns a value, and that value is used to display the total area of the circle. So you get it. Sum is going to take the array, and it's going to iterate over every element of the array. How does that look like? Well, there we go. Sum takes a parameter, which is a reference to an array of simple circle, to an object of class array of simple circle. And then we initialize the sum to 0, so that should be a 0.0 here. I was lazy. Then here's a loop, int I equals 0. Again, counter control loop, iterate over the entire array, and add the area of each circle to your sum. So sum is plus equal, sum is equal to sum plus the area of the circle, and at the end, return sum. And that's it. We computed the sum of all the area of all the circle objects that were in our array. So at this point, once you have had time to digest this a little bit, at this point we should be reaching the level where you are okay with merging what you've learned about method with what we learned last lecture and the lecture before about object and creating object and stuff like that. Okay, so that's the goal of that example, is to kind of like finalize, this is it. You should be able to understand that. And as every time I tell you, this is it, you should be able to understand that. That doesn't mean don't tell me if you can't or if you don't, right? This is quite the opposite. That's a milestone. That's a self-check. So that means, hey, if it's not 100% clear, it's important that you work so that it becomes 100% clear. That's what I mean, okay? So now what we're going to do is we are going to do another one of those like little throwback, okay? And we're going to connect that to what we've done with our swap method. So I'm going to go fast on the slide because this slide is the same slide that I used when we did the swap method. That was one of the very last one. This is the one where I told you, hey, why don't you try now to write a method that swap a string? And I ask you to kind of experiment with that, or at the very least think about it. And in the video, I think this was a video that was recorded asynchronously. And in the video, I told you, okay, I'm going to give you the solution. The solution is that you cannot swap two strings because the class string is immutable. So we are going to talk a little bit more about immutable in a minute or two, okay? But right now, what I would like to do is I would like to use the fact that I can pass references to method to finally be able to swap two integer variables. And I put the term variable because I'm really using it in a loose definition, okay? So you know what we're going to do now? We're going to jump in and we are going to code something that is going to be finally the version of swap that actually works. So let's catch up a little bit real quick on what we had for swap, okay? So nothing fancy. We had like two int that we were swapping. So I'm going to start with that, okay? Int x equal 42, int y equal 23. Okay, and then we had that swap method that was passed x and y, but you know that I'm not passing the variable x and y, right? I'm passing actually the value inside of x and the value inside of y. And then what I had here, so I was displaying before and after, the content of x and y to show you that x and y didn't change. So I'm going to take a little bit of a shortcut here, and what we are going to do now is I'm going to do my public static void swap method that take an int called, I'm going to call it parameter 1 and an int called parameter 2. So this time I don't reuse the same name. Okay, I can do that, no problem. And then I'm going to say int tmp equal p1, p1 equal p2, and p2 equal tmp. All right, this is what I had. So let me compile this, get rid of syntax errors. If I run it, it's not going to do anything right now, but I could put like a little breakpoints here, and then run it with a debugger instead. And now we would be able to see, okay, here's x and y, 42 and 23 respectively. And then I click the banter row, I enter the swap method. So here's my activation record. So inside the main, I still have x equal 42 and y equal 23. Okay, this is the activation record of the main that I'm clicking here. And if I click on the current activation record that I'm using as I run this method, you see that P1 is 42, P2 is 23. And as I execute the code, these guys are going to get swapped. There we go. But when I return, Okay, so the activation record for this method goes away. I'm left only with the activation record of the main, and X and Y have not been changed. Okay, so that's the problem we had. And now what I'm going to do is I want to go beyond this. I want to create a new Java file, and I want to use what I learned to do with constructors, with everything pretty much in module one. So public class, my integer, because I don't have a name, a nice name for this class, so I'm going to go with something very basic. And I'm going to say that my class, my integer, contains a value, which is an int, all right? And then I'm going to create a constructor. So remember the constructor, public. I don't use the keyword void, even though it returns nothing, okay? Just public and the name of the class. And then let's see what parameter we have. So I'm going to say, you're going to give me a parameter v, which is pretty much you want to create an object that represents an integer, and you give me the value of the integer you want to represent, and I'm going to save that inside my attribute. Okay, so that's my constructor, compile. So I need to give a name to the file. First, I need to stop the debugger. Then I need to give a name to the file. So jgrass is nice enough to remind me of all that stuff. There we go. And then, well, I would like to be able to change that value, inside my integer object, change the value and read the value. So I'm going to implement those methods that we talked about, the getter and setter. So I'm going to use that to illustrate, the getter and setter concept that we talked about, like at the beginning of this lecture. So let's start with the getter, public. So a getter, get value, okay? This is a getter method for the attribute value. A getter always returns something because its job is to get the value from an attribute and return it to whoever wants to know what's in there. Because value is an int, I'm going to return an int, okay? Return the value of the attribute value. And then I'm going to have similarly a setter. So the setter method are generally, void, because the role of the setter method is to say, oh, you want to change the value of my attribute. So what do you want to change it to? Well, I'm going to put an argument here. So I'm going to say int v, so that somebody can specify to me, I want to change the value of that my integer object, so that it contains, 99 instead of 23 or 42 instead of 23 or whatever. Okay, so very minimal class. It has a constructor, one constructor. It has a getter. It has a setter. I'm going to stop there, okay, because I don't want to introduce the keyword def just right now. So we have something here that compiles. I can go back to my main and I can say, you know what? Instead of using int, I'm going to use my integer. So my integer x equal new my integer. There you go. So now I'm not using primitive data type int anymore. I'm using a reference data type, and I'm using a reference data type to an object of class my integer. Can I go back to my integer? Absolutely. There we go. Okay, to stay there like a few seconds so that you can catch up. Perfect timing. Meanwhile, I can answer Jonathan's question. So you wouldn't do set first, or does order not matter? So the order here, okay, in the declaration of the class my integer, the order inside the method always matters. The order in which you declare the method, okay, doesn't matter, which means I could take my constructor here and I could put it in the middle, no problem. I could take set and I could put it first, no problem. Everything goes, okay? I could even take my attribute int value, and I guess I should compile to prove to you that, it's still working. So we're going to do that in once again. I could shuffle around, those things like that in the class and then compile, and it's still acceptable, okay? So inside methods, the order of the instruction matters. But when you declare, all that matters is by the end I reach the end of the class, you declared everything that had to be declared, all right? So good question. Is this going to be posted later, this code? Yes, absolutely. So you guys can code along if that helps you, or you can just focus on listening to me and, interacting with me, asking questions. You will have the code after, I promise you, okay? So going back to the main method. So I'm transforming my code here so that now I use my integer. you know, and here I call the constructor. So I create the object, and then I call the constructor, and I tell the constructor that object needs to have a 23 inside of it. This one, on the other hand, needs to have a 42. Then I call swap xy. So if I call swap xy, swap xy is taking an int here. So I'm not done yet with my transformation. I need to adapt my method so that it takes instead, a my integer reference as P1, a my integer reference as P2. And then here, again, I'm going to have to modify the code to use actually the feature of my new class. So if I want to save the value inside P1, I can do it like this. I tell P1, get me your value, the value that you are like saving inside of you as an attribute, and I'm going to save it temporarily to a variable TMP. And then P1, I want to change the value. Well, that's okay. I have a set value method, okay? And I want to set it to what? To the value inside P2. So I call get value on P2. It returns to me the value of the attribute that P2 is holding. I pass that to set value that I ask to execute on P1. So now P1 is going to update its own value, based on what I pass as an argument. And then last but not least, I want to set the attribute inside P2 to the value that I saved earlier, TMP. Okay? Let's compile. And again, the debugger is our friend because now instead of doing a bunch of print system.out.print, etc., I'm just going to keep that breakpoint here, click on the debugger, and we are going to look at in detail what's happening together. So first, I stop execution here right before to call the swap method. What's happening in the main? I have a variable x, which is a reference variable to an object number 213. It's an object of class myInteger. Okay. Y is a reference variable. It has a reference to an object number 214 in memory, which is also of class myInteger. If I click on the little handles here, I see what's inside this object. Each object is of class myInteger, which means it has one attribute named value. All right, this object here referred to by x contains the value 42, which makes sense. This is what I wanted, okay? And the one referred to by y, I'm going to hide this, contains the value 23. So the creation of the object worked. X refers to a myInteger object that contains 42. Y refers to a myInteger object that contains 23. Everything is fine and dandy. Now what? Now I call swap with x and y. So x and y are my arguments. I evaluate them. So the reference inside of x, the reference to object 213, is the value that's passed actually to P1. And the reference inside of y, the reference to object 214, is the value that is passed to P2. So let's execute this and use a bent arrow to go inside the method. See what's happening exactly. So there we go. I jumped inside the method. So now I have two activation records. What's inside the swap method? For now, just the arguments, P1, P2. And look here, P1 contains a reference to object 213, P2 to object 214. If I go back to the main and I look at the activation record, these are the exact objects that were respectively referenced to by X and Y. So yes, the system works, right? I'm passing the references to my object. Going back inside of swap, I'm going to double check what's inside of the object referred to by P1. An attribute that says value is called 42. Perfect. What's inside the object referred to by P2? An attribute that says value 23. So far so good. And then let's do the swap. So here I'm going to execute the whole line, okay, in one shot. I'm not going to go inside to see the detail of what happened when we execute get value or, for that matter, set value. So when I execute this line of code here, it executes the method getValue on P1, which returns to me what's inside of P1, 42, and I put 42 in TMP. Let's see if this is really what happens. Bing, there we go. Local variable TMP just was declared. It contains 42. Then I'm going to get whatever value is in P2, so 23, and I'm going to pass that to set value, which is going to change the value inside P1. So inside of P1, there's 42 here, should become a 23. Let's see if this is what happens. Boom. I got the 23 out of P2. I passed it to the setter method that changed the value inside of P1 so that it's now 23. So both of them are 23. I have one line left to execute. Set the value inside of P2 to TMP. Well, TMP is 42. Here comes P2. So that value here is going to change to 42. Here we are. So I did swap the values inside my objects. Okay? So what's the difference? Well, the difference is that I'm reaching the end of my method. So this whole activation record here is going to disappear. P1 will disappear, P2 will disappear, TMP will disappear, just like before. But the objects that I was referring to, they are not going to disappear. They have been created on the heap over here, okay? And as long as there is even just one reference left to them, they are not going to be destroyed by Java. Remember what we talked about with the garbage collector? Okay, so they are still in memory, and when I return from my method, which I'm going to do right now, boom, all of that stuff disappeared, but my objects are still here, referred to by X and Y, except that now the object that X is referencing has been modified. The content of that object has been modified, I should say. And the content of the object that Y refer to has been modified. So while X and Y didn't change, the values inside X and Y didn't change. These are the same reference to the same object. Now the object contain new values. You can see the 23 and the 42 here. And yes, absolutely, I can go back to my integer. There we go. Let me try to put everything on the screen in one shot. There we go. This is a closing curly brace for the class. Let me compile. Right, so you have the latest version of my integer on the screen. So that's it. We have like approached that's very simple problem, swapping two number, we have approached it in several layers over the course of module 0 and module 1. Now that's the end of the story. Every little thing that was left to explain has been covered, so take the time to digest it. Whenever we finish like that, it should take you a little bit of time to digest, to think about it, to let it, really like hit you, okay? Don't skip over it. It's very important that you understand this. Would the practice for this be on coding bat? So there is no coding bat in this semester, like I mentioned at the beginning of the semester. The only time we use coding bat was for module 0. Why? Because coding bat is very good at doing practice, on COP2513 type of stuff. But for stuff like that, not so much. There are no good exercise. So we're not going to use coding bat for that. So peers would be the best bet. Yes, absolutely. The P's that I gave you, once you know how to complete the P's that I gave you at the beginning of the module, then you are ready for IE. Okay, and don't worry, before you do your IE1, we are going to have also a last live example that's going to be all comprehensive, that's going to be comparable in terms of scope, size, difficulty to what you can expect to see on IE1. Okay, so it's going to be our kind of review session, if you want to call it that. All right. Okay, and that's it. So going back to the slide, and no, the IE1 is not next Monday, okay? Let me do a quick little pause here in the flow of the lecture because this is really important. I want to make sure everybody knows about this right here. So let me grab my browser. So the syllabus section of our course, you all know where it is because you downloaded the syllabus there and stuff like that. This is where you see the TA office hours, etc. But even more importantly, you are going to have a list here of everything that is due and graded. If it's not graded, it's not there. If it doesn't have a deadline, it's not there. But if it is graded and it has a deadline, it's always listed there, okay? So for convenience, I will also add links to the GQs and the IEs, from the module, because last time I didn't do that, and a bunch of students were wondering, where's my IE0? So don't worry, I'm going to make sure that there are links also in the module, but automatically Canvas is going to always put all of your assignment there, okay? So you will be able to see the currently planned dates and time, etc., for GQ1 and IE1. All right. I1 is going to be released the day off. So for you as a student, it might not show up yet. For me as an instructor, it shows up already as Friday, October the 1st is when we are going to have it done. Okay. All right. So I just wanted to make sure everybody was, aware of that resource because it's really, really useful. It helps a lot organize your workflow as a student. All right, so going back to the slide, now we have finally a version that works. And the last thing I'm going to put as just as a remark, we're not going to code it, but I'm just going to mention it as a remark. There is a class named integer with an uppercase I in the JDK. And that class is, well, guess what? It's supposed to represent an integer. So this is pretty much what we created ourselves with myInteger. We created our own version of the class integer. What about using the integer class from the JDK instead of trying to reinvent the wheel? Well, in theory, that would be a great idea. In practice, there's a little bit of a problem. Is the class integer with an uppercase I, just like the class string, is immutable. So that means that while I have a way to do get, like the equivalent of get value, I can look at the documentation, night and day for the next 40 days. I'm not going to find a way to do a set value in the class integer. So that's what it means to be immutable. Actually, being immutable means a little bit more than that. So why don't we finish up today's lecture with just a few slides going over the definition of immutability and finalizing, once again, that topic that we have been introducing in several steps, several layers until now. So here's the definition. Is the content of an object cannot be changed, so the value is inside the attribute, right? If the content of an object cannot be changed once the object has been created, the object is called an immutable object, and its class is called an immutable class. So if you write a class to be immutable, what you create when you create objects of that class is you create objects that are also immutable, okay? So that kind of makes sense if you think about it, okay? So in our examples, in myInteger, if I remove the set method, then the class might be immutable. I'm going to go over exactly what it takes, okay? But it might be immutable. And what about the simple circle class? Same thing. If I remove the setters, generally, then it helps me protect my class from having its attributes, modified. So that would be part of what I have to do to make something immutable. Well, let's take a look at an example that hopefully is going to be, tricky enough to show us, what we need to really pay attention to when we are talking about potentially immutable code. So here's a class student. It contains an attribute ID, an attribute named birth date. The ID is of type int, the birth date is of type birth date, uppercase B, uppercase D. So that's the name of a class that I'm going to define here on the right in one second. And you know how sometimes there was no keyword before the definition of attributes and sometimes there was public? Well, now there's a new keyword private that we are going to completely finish explaining, in the next lecture. But for now, what I would say is that if you say private int ID, that means that nobody can use a dot notation to access ID inside an object of class student. It's kind of like you're locking it down, right? You are not going to read or write my attribute like you would read and write, normal variable just because you use a dot notation. I forbid you to use a dot notation on that attribute, pretty much. Okay? So if I forbid you to use the dot notation on an attribute, that means that either you should not even know about that attribute, it's only used internally in the class, or there are other ways to potentially, change the attribute or read the value of the attribute. Well, that's exactly what's happening here. See this? This is a getter. Public int, so this one is public. Public means it's not locked. This is what we have been using by default since COP2513. By default, everything we wrote was openly accessible, no constraint. So public int get ID, you call that method, and it returns the value of ID, even for ID is private. It's locked inside the method. And then if you call get birth date, same thing, it returns the value held inside the attribute birth date, okay? And then you can do whatever you want with it, which is actually going to be the source of our problem, as I'm going to explain in a second. So I have two getters, no setter method, which makes sense, okay? I don't want people to be able to change the ID or the birth date. Once the object has been created, that's it. It should not be, the attribute should not be something that you can modify nilly-willy. So here's my constructor. My constructor takes a social security number, a year, a month, a day. The ID of the student is going to be his or her social security number. The birth date is going to be a reference to a new object of class birth date, to which I'm going to pass the year, the month, and the day. And here's a class birth date. It has a year, a month, and a day as attribute. All of them are int. All of them are private. So we are starting to use that lockdown, the attributes so that people cannot mess around with them. My constructor, which I'm calling here, takes the year, a value for the year, a value for the month, a value for the day, assign them to the corresponding attribute. That's what constructors do, right? They initialize all the attributes in an object. And then I have a setter that allows me to change the value of the year if I made a mistake, or I guess if somebody invents a time machine or gets suddenly younger or older, I don't know. Anyway, we can change the year, but that's it, okay? We cannot change the month, we cannot change the day, we can change the year. So the question now is, when I look at an object of class student, I did some work here to make sure that, it would be immutable. Like the ID cannot be accessed, the birthday cannot be accessed. I have getters, but I don't have setters. So it looks like I locked down my attributes so that once they have been created, they can no longer be modified. Is that true? Is this class immutable? Well, we are running a little short on time, so I'm going to spoil it, okay, for you. And I'm going to tell you, no, it's not immutable. Okay, it's not immutable, and it's actually a little bit sneaky why it's not immutable. That's why we are using this as an example, and I want to show you exactly what's happening. So let's try to find a way to quote unquote hack this class. Everybody is misusing the word hack, so I'm just joining the bandwagon. If you cannot fight them, join them, I guess. So we are going to actually play around, I should say, tinker with that class, try to create objects, and try to get to the point where we are going to be able to modify something inside those objects after creation, thus showing that, that object is not immutable. So here's a class test, separate file. It has a main. I create an object of class student. Here's my social security number, the year the student was born, the month, I think, was the second, and then the day. And then the birth date equals student.getBirthDate. So after I create the student, I use a getter. There's nothing wrong with using a getter, right? First, when the student is created, all the attributes are private. Now I use a getter to get a value, so I'm not changing any value, right? And I get a reference to the object of class birthdate that is inside the attribute birthdate in the student. And then here's where I mess up everything. I use that reference that I got. And the problem is that while student is actually well written to be protected, the birthdate class has a setter. So inside student, we have a reference to a birthdate object. And really the whole information about the student is encompassing that information about the birth date, right? Well, if I just ask politely to the student, can you give me a reference to your birth date object? The student will gladly comply. The student object will comply and give me that reference. And once I have that reference, I can change the year of the birth date. And any change that I apply here is going to reflect also inside the object student. Because both the object student with its attribute birth date and my main method with its local variable date, we are referencing the same object. So what we learned about references, what we learned about passing parameter to method, everything is tying together. What we mentioned about immutability, everything is now tying together in this example where I kind of show you, how sharing reference on object goes beyond just passing parameter. It can happen in all sorts of contexts in your class, but the rule is the same. If two variables refer to the same object, then both variables can be used to access that object. And then when we talk about accessing object, well, as long as you have only getters, you're okay. Okay, so this is okay to get the birth date, but no, it's not really okay because now I can use that reference to call a setter. So this whole thing here, those two classes together, they are not actually immutable. All right. And then I'm going to put another example here. What about this one? So I modified the class student, and now the class student has a get name and a get ID. So it's not exactly working the same way. I don't have a birth date anymore, but I do have another field instead of birth date that is still a reference to string, and I still return, the reference to my object that is referred by my attribute here. I return it to whoever wants it. So does this class have the same problem? No, it doesn't. Why? Because this time, when I return a reference to name, it's true that I leaked some information that could be potentially used to modify name, except that name is of class string, and string is immutable. So yes, you gave the key of your car to somebody, to a random stranger, but you made sure that there was no gasoline in the tank. So they're not going to be able to do anything with that car. Okay? So immutable classes, it's an interesting concept. Make sure to take the time to think about it, read the reading assignment. To conclude for today, what did we learn about immutable class? Well, there's a checklist. You need to make sure that all the data fields are private so that no data field can be modified using the dot notation. Then you need to make sure that you provide no, it's called a mutator. I haven't introduced that term yet, but an accessor and a getter, is called an accessor as well, and a setter is called a mutator. So I told you about the vocabulary and the synonyms, watch out for that. So no setter method. And then last but not least, if you return a reference to an object, make sure that that object is also immutable. Otherwise, this is a potential for like a security flaw, pretty much. Okay. All right. We are going to stop here for today. Thank you so much for your attention. Sorry, being 1 minute overboard. You know the drill. We transition to office hours, so hang around if you have questions. I'm going to stop the recording, and you can start firing any question that you can think of. Thank you again for your attention.